actually get to lift it like that in real life unless you cut it. Okay, but on our little model right here, that's how I'm kind of representing it. All right, you wouldn't get to do that. Well, I guess you could, but I don't know how well the person would, you know, like for that to happen. But anyway, this flap, all right, is called the auricle. This little area right here. My atria, which I don't really get a good view on any of our models, but where this would be the right atria, over here where this flap is, if it would flip up, this would be my left atria, and in between them, can you guys kind of see where my finger's pointing? Okay, there's a wall, and that is my because it's between atrial, and it's a wall, so it's a septum. Okay, is everybody with me on that one for the structure? Okay. The ridges that you're going to find on the inside, can everybody kind of see these ridges? Okay, those are called pectinate muscles. This is where they're found, okay, in this atria of the heart. For my ventricles, this is the part that when, okay, it will eject the blood out of the heart. Once again, there's a wall in between the right and the left, okay, interventricular septum. All right, but definitely different in structure, okay? They have internal ridges. I don't know if anybody can kind of see that. Kind of see those ridges? Those ridges? Okay. These ridges? Okay. You see those ridges? See those ridges? And then these ridges.
Do you have your 18 study guide?
Okay. Those are going to be called trabeculae because they look like the trabeculae of the spongy bone. Does everybody remember that? Trabeculae carneae. Go for it, right? So, on the surface, like I showed in the picture, the boundary between atria and ventricles have the sulci. Does everybody kind of see that going around? Okay, Marlisha, can you see that back there? Okay, and then anterior and posterior look like they have the sulci separating the right and left on each side, okay? These sulci have the fat in them, and they're protecting my coronary blood vessels. The sulci around and between that we see are my area for my coronary blood vessels. Well, good gracious, don't have coronary. Ever heard somebody say that? What does it mean?
Heart attack.
Don't have a heart attack. What? Huh? They had a coronary. They're telling you they had a heart attack. They had an MI. A myocardial infarction. Myocardial, meaning cardiac cells, cardiac muscle cells. Infarction, they lost the ability to work. They had a heart attack. I wonder what the connection is between my coronary blood vessels and the function of the heart is. I wonder. We're going to come back to that because it's really, really cool. It really is. So, like I said, coronary sulcus going around. Those interventriculars are in between the ventricles on the anterior and posterior sides. Really cool structure. So, that is the stuff that I was trying to point out. I was trying to point out if we could, like flip that little auricle open, all right? We've got little ridges, and because they look very much like the little trabeculae of spongy bone, okay? Now, a couple of other things to kind of look at here, because this would be like we took the heart and just cut straight through, and we're kind of like just opened it like a book, and we're looking at one side. Well, we're kind of looking towards the posterior side of it. Now, a couple of things I want you to note. Atria, ventricles, okay? Cardiac muscle is greater on the left ventricle than the right. Cardiac muscle is greater on the left ventricle than the right. Why?
That's the origin of its movement.
I guess the
Pump the blood to where?
other organs.
To all other organs of the body. It has to be strong enough to get the blood to the tip of your toes. On the right, why does it not need to be as strong?
Because the return blood's going to the lungs.
It only has to go to the lungs. It does not have far to go. And if it had a bunch of strength getting pumped to the lungs, it would explode them. So on the right, the left has more cardiac muscle than the right because of the area it has to move into. For the valves of the heart, on my right side of the heart, I find a valve between my atria and my ventricle. On the left, I find a valve between my atria and my ventricle. Is everybody following me? All right? These are termed atrioventricular valves. And because I have one on the right, it is termed the right atrioventricular valve. Because this one is on the left. This is my left atrioventricular valve. Their job is controlling blood movement from the atria to the ventricles. Don't worry, we're going to come back to that. All right? When I look at my great vessels, from the right, the blood flow moves into my pulmonary trunk. From the right, my blood flow is into the pulmonary trunk. And that great vessel has valves. On the left, blood moves to the aorta, and it also will have valves. For my atrioventricular valves, the valves that are in between atria and ventricles, does it look like they have strings attached to them? Yes. And then it looks like those strings are attached to a mountain of tissue. Does everybody see that? All right. Over here, strings. Here's my mountain. Strings, mountain, strings, mountain, strings, strings, mountain, mountain. Those structures become very important in controlling how the blood will move from my atria to my ventricle, whether on the left or the right, okay, and making sure there's no backflow. So making sure that the blood that moved from the atria to the ventricle doesn't go back from the ventricle to the atria. Right?
Did they move away from calling them like mitral, bicuspid,
No.
tricuspid?
I just hadn't gotten to that point
Okay.
yet. Okay? Yes. You may have heard these being referred to as, for example, bicuspid, tricuspid. Yes, no, maybe?
Yes.
Can you look at this picture and tell me why?
Was it the amount of cusps?
Yeah.
Marlisha?
Yeah, because I've got like two little mountains.
Yes.
So I got more short.
And the way that you can tell that, bi means two. Look at my left ventricle, there are two mountains. Look at my right, there are three. On the left, we also know it as the mitral. The one that people can have issues with and get replaced. Most of the time, that's the one with the issues. The reason that I'm pointing all of this out, these areas become important for function of the heart. Why would that be clinically significant? If your heart ain't pumping, we ain't here, right? So, clinical significance. And lots of things can go wrong with all of it. All right? The functioning of the heart is a huge area of study.